Wherever there's gold to be found, pirates are never far away. If pirates were once keen on jewels and gold, then today they not only plunder products, but also the treasure of know-how. And they copy these precious goods unscrupulously. Product piracy costs the German economy billions. Germany's most important employment sector, the engineering industry, is particularly hard hit. The latest studies by the VDMA, the German engineering industry, show they face losses of around 6.4 billion euro. This corresponds to a rate of 4% of the sector's 161 billion euro total sales. If this is translated into jobs, then we could be talking of around 40,000 jobs being at jeopardy. 82% of all counterfeits originate in Asia. Alarmingly, the forgers are becoming increasingly bold, copying everything, not only consumer goods but also spare parts for machines, and even the whole manufacturing plant itself, sometimes even including operating instructions. But the German engineering sector, a global market leader with an outstanding reputation, is no longer prepared to just stand by and watch. It's created a joint venture. The VDMA Working Group Product and Know-how Protection focuses on the development and application of technological protection against counterfeiting. Basically, we distinguish between four main fields of technology. First, forgery-proof markings for products, so that the original can be identified at any time. Second, tracking down the routes of transport to prevent the infiltration of counterfeits. Third, technical measures within the products to make counterfeiting more difficult or even better, impossible. And fourth, the protection of know-how through cutting-edge IT technology. A customer needs to be sure that there are no interior and dangerous bogus parts within the machine. And the original manufacturer needs to know that the equipment that they're providing a service and warranty for is operating with original parts. Product identification and labeling is one way of ensuring this. This pipsqueak is just 0.9 of a square millimeter, but it delivers a great deal. It's an RFID chip. That stands for radio frequency identification, and it transmits its ID via radio waves. It's cheap, uses very little energy, and is very difficult to fake. These chips are forgery-proof mainly because they have what is called a safe memory that holds a secret code. To uncover this secret code would be an extremely complex process. To find it and to copy it into a new chip would be exorbitant in terms of time and effort for any hacker. Asymmetric cryptography is the magic word. Until recently, experts believed that asymmetric cryptography on an RFID chip was impossible. With the asymmetric approach, the secret is held only within the chip, and the checking part doesn't need any secret keys. Using this technology for intellectual property protection, we can check products for authenticity, decentralized, and all over the globe, without having to distribute secret keys. Let's say a hacker tries to clone the new chip. He manages to successfully read the identity and the certificate, and he copies them onto another chip. The chip is then installed in a fake product. In this case, it's a watch. A reader device recognizes the identity and the certificate of the cloned chip and registers that the verification was successful. But a check of the secret key fails because it couldn't be copied by the hacker. The product is exposed as a fake. Anti-theft devices are now well known, but only for cars. This solution shows that now even knitting machines can be equipped with them. Through protected, embedded software, the machine recognizes when the predetermined number of units has been achieved, and the production line stops. So the extra shifts and night shifts often run, for example in Asian countries, come to a grinding halt. Hard encryption within smart card chips integrated in the code detector protection hardware for industry is the anti-theft device for machine software and production data. As well as encryption, technology is a crucial tool for modifying programs and data so that we can use them, but the counterfeiters can't copy them. The software also helps to make it harder to reproduce a machine and even protects knitting patterns, that is, intellectual property which is also frequently faked. Protection against forgery with labels, for example by using a hologram. They can be integrated in the product or as part of the logistic seals, and they even look good. Combining systems offers even greater security. On this label, we've combined several security technologies such as true colors or two-dimensional holograms. There are colors that change according to the viewing angle, or hidden markings that are only visible under infrared or UV light. And of course, we have digital information such as barcodes or alphanumeric codes for authentication. Another variant is the self-adhesive label that is destroyed as soon as someone tries to remove it. This is another example. It's how Bosch Automotive checks its original spare parts for authenticity. We've installed a closure seal with a 15-digit alphanumeric code that can be entered on the internet. This allows the authenticity of a product to be checked worldwide. You enter the code here, and receive the message that it's an original product. Product authentication is already possible using a mobile phone, a system well appreciated by customs officials. This product could be a copy. Soon, consumers too will be able to determine if that T-shirt is an original or a fake. The development is an ongoing process. The German Ministry for Education and Research is funding several projects dealing with innovation against counterfeiting. Various partners from industry and universities contributed to this project, developing together technical and legal solutions as well as risk patterns, all carried out as teamwork and, from my point of view, with remarkable commitment from all team members, and taking place in a very frank and open atmosphere. Here, research is taking place into joint future solutions for the protection of machine tools and their component parts. Using the intelligence of machine control, a prototype is being created that is globally unique so far to check the authenticity of components. What's new is that the existing communication interfaces can be used. The prototype is able to determine the current machine configuration and compare it with the out-of-the-box state. Variations are recorded automatically and visualized. The manufacturer is able to reject recourse receivables if necessary, and the client has a tool to help him recognize forgeries, which isn't always easy as frequently they're very skillfully faked. The German engineering industry produces high-quality products, it has a very good reputation and is obviously a main target for fakers. But the industry is going on the offensive across a broad front. Counterfeiting is a big challenge, not only for German industry, but for industries worldwide. The Hanover Fair is taking on this challenge. The Hanover Fair, under this year's comprehensive slogan, "Get New Technology First," is the ideal place to show representatives of global industries how intelligent solutions can help us all confront the challenge offered by counterfeiting. This year, for the first time, the Hanover Fair will focus on this topic and provide efficient solutions in the fight against product piracy. Together, through a concerted effort, we'll be able to drive off the pirates.